All right, now we're going to learn how to calculate the following quantities: the hydrogen ion concentration, the pH, the pOH, and the hydroxide ion concentration. All right, so anytime you see these brackets in chemistry around something, they mean the word concentration. Okay, so we've got this letter H, which stands, of course, for the element hydrogen. This plus sign, which is the word ion. And this bracket, which stands for concentration. Now remember, concentration is how much of your solvent you have in your solution. Okay, so the hydrogen ion concentration of a strong acid is equal to, that's what this big capital M is, the molarity of the solution. Now remember, what makes something a strong acid is not its concentration. These are not the same thing, okay? So they're not equal to each other. The word strong acid, remember, has to do with where they are on the list of acids. So there's a list of acids: nitric acid, sulfuric acid, perchloric acid, chloric acid, hydrochloric acid, hydrobromic acid, and hydriodic acid. That's the list of strong acids. So if you are one of those acids, your hydrogen ion concentration is equal to your molarity. So if you have a 6 molar solution, the hydrogen ion concentration is equal to that, is equal to 6. So the hydrogen ion concentration equals the molarity of a strong acid. That's important to note because it's how you're going to calculate the pH, the pOH, and potentially the hydroxide ion concentration. If you're a weak acid, there's a different formula. The weak acid, the hydrogen ion concentration equals the molarity times the Ka, and then the square root of all that. So the square root of the molarity times the Ka. Be aware that the Ka value on that is most likely going to be a number in scientific notation. And if you are using the times 10 to the method, like if you say times 10 to the 2 or times 10 to the 12, that's what I wrote here, sorry, and instead of E12, then your number that is your Ka value has to be in its own set of parentheses. So you would have to open parentheses, molarity times, open parentheses, your Ka value, close parentheses, close parentheses. And all of that is under the square root. Okay, so all of that under the radical. All right, so the weak acid. Now, how do I know I'm a weak acid? Think about it for a second. How do you know that you are a weak acid? Hopefully you said because you're not a strong acid. There is a list of 7 strong acids, and if you are not one of those strong acids, then you by default are a weak acid. So by default, you become a weak acid if you are not a strong acid. All right, let me get a pen back because, okay. You got to know your calculator. So I have the 2 main kind of calculators that people have or should have. If you have the Texas Instrument, that's an A calculator that you were forced to get in the middle school. Hopefully you realized back in stoichiometry that that wasn't the calculator for you. If you didn't and you're still using it, I don't have a picture of that one because that's my least favorite calculator in the universe. You got to find these buttons on your calculator. So first of all, you're going to be using the negative button, and the negative button is here circled in yellow on these two calculators. So depending on which calculator model you have, yours may not be in one of these two places. Find your negative button. It's not the same thing as the minus button. All right. The other two buttons that we're going to need for this minimum number of two buttons that you're going to need is you're going to need your shift, because we're going to not only do the log, but we're going to do the second log, which is above the log right here. So the shift and the log are both needed. So you need the log button, which is right here out in the open on both of these calculators, and then either the shift log or the second log, depending on the brand of calculator you have. All right, and that's the button that has a 10 with to the X on it. So that's what it says up there. It's hard to see because it's little, but that is the shift and then the log, or the second and then the log. Okay. The other buttons that you might need on your calculator is putting a number in scientific notation. So on my favorite brand of calculator, the EXP button is right out here in the open. So if I am putting a number in scientific notation, I just have to put, say I'm putting 1.2 times 10 to the 27, it's 1.2 EXP 27. On this calculator, if I want to do that same number, it's going to have to be 1.2, and then the times button, and then the 10, 10, then the to the button, which is this little caret, and then your 27. So that's how you get it to be the same as the EXP button on this mode of calculator. All right. So first of all, make sure you know the calculator that you're using. You know how you know the calculator that you're using? When I do the practice problems, you practiced along with me. Don't just watch me do the problem or pretend like you're doing the problem, because if you don't recognize where the buttons are in your calculator, you won't be able to check your answer to the answer I'm giving, and then we can't troubleshoot right away what is wrong with your calculations. We don't want to find out on test day that you don't know how to use your calculator. Okay. All right, so we're going to be using this square, which I often call the pool. I'll say, which side of the pool do you need to jump in on? And a variety of different calculations will have to be done depending on what you're trying to do. So if you are dealing with the hydrogen ion concentration, you're going to jump into the pool over here on the left-hand side. Now, you can jump into the pool on any one of these four corners given the number that you're given, but in this section right now that we're working on, eventually we'll do more, but in this section, they're starting out with us having molarity, and molarity of an acid jumps in to this left-hand side of the swimming pool. If you're talking about a base, you would jump in to the right-hand side of the swimming pool. That's the hydroxide ion concentration. And from that, you can determine all the other four pieces on this square. So you could figure out the pH, and you can also figure out the pOH of your solution. All right. If you start at the hydrogen ion concentration, and you are wanting to get to pH, or if you're wanting to get to the hydroxide ion concentration, you would do one of these two things. So you got to follow the color-coded line here. So if you're at the hydrogen ion concentration and you want to get to pH, you're going to take the negative log. So come over to your calculator. You're going to take the negative log of whatever your number was for your hydrogen ion concentration. So you're going to take the negative log of whatever that number is, and then of course equals. If you want to go from pH then to pOH, or from pH up to the hydroxide, hydrogen ion concentration, if you're going up this orange line, you're going to take the shift log of your negative pH. So that means the shift and the log, that gets me to the 10 to the x. If you shift log, you're at the 10 to the x. So shift log, and then negative sign, see that's a negative sign right there, of the negative whatever number you had. So let's say you have a pH of 3, for example. To get to the hydrogen ion concentration of that, you take the shift log of negative 3 equal sign. So that's how you get to that. All right. So if you want to go across the bottom of this calculator, it works the same way on the other side, up and down on the other side. If you're going down, it's negative log. See, look, if you're going down, negative log of what was up here. Here it's negative log of what was up here. This, if you're going up, it's the shift log of whatever you had right there. So the next transaction is to get from pH to pOH. So the pH scale is numbers, technically from like 0.1 or whatever. I say from 0 to 14, with of course 7 being the halfway point. Your pH plus your pOH add up to the number 14. Your pH plus your pOH, your pH number plus your pOH number add up to the number 14. So if this number is 4, then your pOH is 10. If this number is 3, then your pH is 11. So the two numbers add up. I will let you know the numbers on this side, the pH of the left-hand side, are all going to be numbers less than 7. And that's because the pH scale, 7 is neutral. Anything less than 7 is acidic. Anything greater than 7 is basic. So the two numbers add up to 7. And across the top, to figure out to go from the hydrogen ion to the hydroxide ion concentration, if you're going to the right, it's 1 times 10 to the negative 14 divided by whatever number you had there. And if you're wanting to go the opposite direction, it is 1 times 10 to the negative 14 divided by your hydroxide ion concentration. Okay, so you got to know your calculator, and you got to know this square. You got to be able to memorize the concept. If you're in regular chemistry, you get to have this on the test. If you're in honors chemistry, you have to know this by heart. So the way I memorize this is if I am going down, that's because the first thing, they all involve, by the way, the word log. Okay, so the up and down motions both involve log. So one of them is the negative log, and the other one starts out shift log. So I've got to know the second word is always log. So I have to decide whether it's negative log or shift log. And the way I memorize it is if I am going down, that is because the first thing I did was something negative. So I kind of think of it like good and bad. If I'm going down, if I'm going to go down to where the devil lives, the first thing I did was something negative. If I'm going to go to up, like I'm going up to heaven, then the last thing I would do is something negative. So if I'm going down, it's the negative log of whatever that number was. And if I'm going up, it's the shift log of the negative whatever the number. If we go back to that example of 3, it would be the shift log of negative 3. Okay. All right. So know your calculator and know how to operate going back and forth between these items. This is back and forth that equals 14. That makes it easy. And to tell you the truth, I usually kind of avoid this one because then that's more pushing of buttons. Because if I want to get to over here, I can actually go here, here, and here to get there too. And most of the time they ask me about these other aspects as well. So I might as well just go around the square. All right. For example, I've got nitric acid and it's dissociating into hydrogen ions and nitrate ions. The first question to ask yourself is, this is the equation for you. Is nitric acid a strong acid? The answer, of course, is yes. That is because nitric acid is my no in the no-so, clo, ClBrI, that I memorized for myself of the strong acids. So they're going to give you 0.0004 molar nitric acid. This is its concentration. It's not very concentrated. It's 0.0004 molar of this strong acid. All right. So what I want to do is I want to go all the way around the square because they're asking me to find the H plus, the OH minus, the pH, and the pOH. Okay. So I want to be able to go all around the square using that number. So the first thing I'm going to have to do, let me go back and get the number, 0.3 zeros and a 4. 0, 0, 0, and a 4. Oh, I think it's going to tell me it. Okay, so if my hydrogen ion concentration, now why is it equals 0.004 automatically? I jump right into the pool on the H plus side because it's a strong acid. Molarity equals the H plus. So now I'm up here in this corner. Remember, I'm at my hydrogen ion concentration. It automatically is 0.0004. All right, so now I want to get to pH, so I'm going down. If I'm going down, I'm going to take the negative log of, so in your calculator, you hit negative button, you hit log button, and then 0.0004, and then equal sign. So in your calculator, hit negative log 0.0004 equal sign. When you hit that, you should end up with 3.4. By the way, pHs are to the 10th. Those are typically to the 10th. Every once in a while, you do see them to the 100th, but you don't ever see them beyond that. So you might say 0.3, and in this case, it would be, if you did it to the 100th, would be 0.40, because the 39 would have rounded to 40. If they told you to do to the 100th, you would have done 0.40. So anyways, 3.4. Now I'm down here on the square with 3.4 at pH, and I've got to go across to pOH. Remember, pH plus pOH equals 14. So what I do is I automatically just say minus 14 in my calculator. Now, when you do that, by the way, you're going to come out to having a negative number there. And I'm going to write it here for just a second so you saw what it said. But pHs and pOHs are never negative numbers. So don't put the negative sign on it. All right. The reason I do it that way is because when I head up to do my next set of calculations, just going to move that out of the way for you. I am going to take in my calculator, because remember now I'm going up, I'm going to take the shift log of my negative answer. And my answer is already negative now because my calculator says right this minute, negative 0.6. So I'm going to take the shift log of my answer because I already have the negative 6 in there. I mean, the negative 10.6 in there. If yours has a positive number, then you're going to have to take the shift log of the negative 10.6. When I do this calculation, this next calculation to go up, I'm going to take the shift, this is the buttons I'm pushing, the shift, the log, and then negative answer. but mine already has a negative number, so I'm just going to hit answer. So I don't know if that's going to confuse you or not. So maybe after this, I'll clear it out. And so it doesn't, I'm just telling you what I do because I don't want to hit too many things. So to go up, so let me click here because we've got the pOH of 10.6. To go up on this next one, I'm hitting the shift. My number's at 10.6. The shift, hurry, log, negative, answer. Because in my calculator, I am looking at 10.6. I don't want to clear it out to the end because I'm technically looking at 10.602.05999. So I don't want to clear it out until the end. Never round anything until you get to the end answer that you want to have. If it tells you to answer these pieces to the 10th, you answer them to the 10th along the way, but you don't round until you're putting something in an answer box. So I want to take the shift log of my negative pH. And so I end up with 2.5. And don't forget the times 10 to the negative 11 part of it. A lot of times people forget. Now the two things that have units on it are the hydrogen ion concentration and the hydroxide concentration. The units of it are molarity. It's a uppercase, capital M. Be careful. It is not the same thing as you putting a lowercase m, and that will be marked wrong in both honors and regular classes. So you cannot put a lowercase m there. That means meters. Okay. All right. So hydroiodic acid dissociates into hydrogen ions and iodide ions. Then the question says, given 0.25 molar HI, calculate the remaining pieces, the hydrogen ion concentration, hydroxide concentration, the pH, and the pOH. The first question to ask yourself is this a strong or a weak acid? So hopefully you know that is your I in no, so, clo, Cl, Br, I. So this is a strong acid. If it's a strong acid, you jump right into the pool with the exact same number that you had a minute ago. So on my calculation, it was 0.25. So on my square, up here, jumping in is 0.25. Okay, so let's go through the calculations. So 0.25, I want to go down. So to go down on this, I'm going to take the negative log of 0.25. So in your calculator, negative log 0.25. And your answer should come out to, for your calculations, to 0.6 as your pH. Now remember that number plus the pOH is equal to 14. So this number is 13.4. Now I want to go up. If I want to go up, I want to take the, I'm going to just fill in the whole thing for you. I'm going to take the shift log of the negative pOH. So the shift button, log button, negative answer button. On my calculator, there's an answer button here that I use. On the Texas Instrument, it's a shift, and above the negative sign, I believe, is where your answer button is. So the shift log of my negative answer, and I end up here with 4 times 10, that's an E, 4 times 10 to the negative 14. Okay, so when you're looking at your calculations, your 0.25 went to 0.6. This is the check of our work from the last slide. 13.4 and 4 times 10 to the negative 14. There's no space between here and here. All right. Hydrochloric acid, is that a strong acid? That's what you have to ask yourself. It is. It's the Cl in no, so, clo, Cl, Bri. Those are my 7 strong acids. So that means this molarity jumps me right into the pool as my H plus. Molarity equals H plus for a strong acid. So 0.005 is the question that I'm going to jump in with. So 0.005. That is my hydrogen ion concentration. That is my hydrogen ion concentration. So if it's 0.005, then I want to go down. It means I'm going to take the negative log of 0.005. So I'm going to take the negative button, log button, 0.005, and the equal button. So my pH is going to be 2.3. Now remember, these two numbers add up to 14. So just the numbers in my calculator, I just say 14 minus my answer. 14 minus my answer. And I get 11.7. It's technically on your calculator 11.69897, but we round that to the 10th. That's where pH is round. And like I said, sometimes to the 100th, but typical default is to the 10th. And then now I want to go up. So to go up, I'm going to take, that stays in my calculator. I'm never clearing my calculator this whole time. I'm taking the shift log of my negative answer. And my answer at the hydroxide ion concentration is 2 times 10 to the negative 12. Okay, so the next slide is going to check our answers. So when I started out with 0.005, then remember I was going down. So I took the negative log of 0.005 equal sign. That's where I got 2.3. To go across the bottom, I did 14 minus my answer. And when I did 14 minus my answer, I got 11.7. And to go up, I'm going to take the shift log of my negative answer button. The shift log of my negative answer button. And I end up with 2 times 10 to the negative 12. All right, for a weak acid, and honor students, you're going to do weak acids and strong acids. Regular students, you can go ahead and work on your homework assignment. You only have strong acids for right now. And you could fast forward to figuring out bases. You will have strong bases, so you could fast forward until you get to the thing that talks about strong bases. All right, so concentration of weak acids, honor students. To figure out the concentration of a weak acid, it is the square root of the molarity times the Ka value. And the Ka value, just to let you know, is going to be provided for every acid, both strong and weak. You have to know when to use it. When do you use it? When it's a weak acid. How do you know it's a weak acid? Because it's not a strong acid, which I have memorized. The strong acids are no, so, clo, Cl, Bri. Go back and look at your weak and strong acid list if you don't know what I'm talking about when I say no, so, clo, Cl, Bri. All right, so that is going to equal my hydrogen ion concentration. So I don't get to jump right into the square. So this is telling me I've got, this is hydrogen cyanide or cyanic acid, hydrocyanic acid. And this is what I am starting out with as my molarity. Okay, and they're going to give you a Ka value. These two things will be given to you in the problem. So you're going to take the square root of 0.004 times 6.2 e to the negative 10. and oops, I ran out of space, and close your parentheses. So you could take those two numbers, oh, I missed a 0 in here. So take in your calculator 0.000, 3 zeros and a 4, and times it by 6.2 e negative 10 and say equal sign. That number came out to be 2.48 e negative 13. That's what's in my calculator right this minute. And then take the square root of your answer. So this is in the window of your calculator. Take the square root and then say of the answer. So that's in your window. Go up and find your square root button. I'll show it to you in a second. The square root and then say of your answer. There's an answer button on your calculator too. And you're going to end up with the hydrogen ion concentration. You might want to put it in, if it's got more than 2 zeros on it, you're going to put it in scientific notation. So 4.97 E negative 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yeah. Okay, that's a 7. All right, so the first thing that you do, I'm going to show you where those extra buttons were on your calculator. So the square root button is right here, and the answer button on my calculator is down here. If you've got a Texas Instrument button, take a minute to find those spots on your calculator. All right, so when I first jump into the square, I get this number, and I take after I put 0.004 times this in my calculator, and then I hit the square root of my answer. So I end up taking the square root of my answer after doing those two things. Now, you can hit the square root button and do all your parentheses and set the problem up exactly like this, and it will work out too. I just find it easier to multiply these two and take the square root of my answer. So you do what's right for you. Make sure, check that you're doing it right first. Don't say, hey, I like to do it this way, but you don't get the right answer. Well, then that's not one of the right ways to do it. So there is multiple right ways to do it. Make sure the way you're doing it comes out with this answer. If it's not, then you might want to go back and rewind this video and see how I said to do it. All right, so this is in my calculator, and in my calculator actually says 0.000000497. That's what my calculator says, but never write a number that has that many zeros in the front without putting it in scientific notation on a test coming up. So if you got maybe 2 zeros, and then after that you start putting it in scientific notation. All right, so that's my number, and it's sitting in my calculator, and I want to go down. Remember, that means I'm going to take the negative log of the answer that's sitting in my calculator right now. Don't write that down and type it all back in. Just take the negative log of your answer. So take the negative log of your answer, and then hit the equal sign, and you're going to get to 6.3. Now remember, 6.3 plus the number that's my pOH add up to 14. So to get the next piece of the puzzle, you do 14 minus your answer, and you're going to get 7.6972, so 7.7. Now I'm at pOH and I want to go up. I don't take that out of my calculator. I do not take that out of my calculator. I am going to take, because I want to go to heaven, I want to take the shift log of my negative answer. And because the last thing I would do is negative if I'm planning on going up to heaven. So the shift log negative answer. And I end up, and you could change your calculator mode to give it to you in scientific notation, but it's going to give you everything then in scientific notation. So you might want to learn how to put a number. You just move the decimal point as many places as it takes to get one number in front. So 1, 2, 3, 4, 5, 6, 7, 8. So my number comes out to 2 times 10 to the 8. And that's a negative when there's a whole bunch of decimals. So 2e negative 8. So 2e negative 8. That's what you write for this answer. That's 0.000000002. Okay. So that's all right. So let's try another one. I've got hydrofluoric acid. Is hydrofluoric a strong or a weak acid? It's not part of no, so, clo, Cl, Bri. So that makes that a weak acid. If it is a weak acid, remember, I'm going to take the square root of the molarity times the Ka value, which in this case is 6.7 E negative 4. They're going to give you both of these numbers, unless you're having to calculate this one, that's a possibility as well. But they're always going to give you the Ka value. You're never going to have to do that. Come up with that yourself. Every acid has its own Ka value. So try that. Put your numbers in your calculator. 0.25 times 6.7 E negative 4. Remember, that's not a minus 4. You get that number, then you take your square root of your answer. That's where you jump into the square. Okay, so the number that you're getting now that you jump into the square in is the number in your calculator window. Okay, so for that calculation, you should have come up with 1.29 E negative 2. Could you have said for this particular one 0.0129? Sure, that's the same thing. 1, 2 places, that's why it says negative 2. When you put a number in scientific notation, it's how many places did you have to move the decimal point to get one number in front of it. Now, we've been doing that for multiple things back in stoichiometry, so that should be something you know how to do. Unless you're new to my class, then you should know that. And if you're new, go look up something on how to do scientific notation. All right, so once there's a video on it back in my Canvas course. All right, so once you're here at the H+, remember I jumped into the pool over on this side of the pool. Now I want to go down. Okay, so when you go down, that's because you did something negative first. That means you're going to take the negative log of the button that says answer on it. So take the negative, not minus, the negative log of your answer, and you'll end up with the pH, because now I'll be down at the pH. Oh, they did the pOH first. Now I want to be at the pH. So then I'm down at the pH squared. It doesn't matter which one. It asked me to do all of them. So my calculator says 1.88. Remember, we're rounding to the 10th. That's why I said 1.9. Then if I want to get over to pOH, remember these two numbers add up to be the number 14. So I take 14 minus my answer, 14 minus my answer, and that gets me to 12.1. And now I want to go up, and so that means I'm going to take the shift, which, by the way, the shift button is up at the top of your calculator. So when you want to go up, I say, oh, I want to use the button that's up too. So on the calculator, it's up at the top. So that's why I say if you're going up, that's another mnemonic tool for me. I use the shift button. Shift, log, negative, answer. And I end up with the 7.75 times 10 to the negative 13 that I had there. It told me it just went across the top of the doofus square instead of going around the bottom. They asked me for all of it, so I have a tendency to go down and around so that I don't have to use the times 10 to the 14 button. I know that seems lazy, but I'm less button pushing. All right, so I've got hydrobromic acid. Is hydrobromic acid a strong or a weak acid? I've given you 0.169 molar of hydrobromic acid, and it wants you to find the hydrogen ion concentration, the hydroxide ion concentration, the pH, and the pOH. Pause the video and do the following calculations and come back and see what the correct answers are. Okay, so your hydrogen ion concentration was 0.169. Okay, so your hydrogen ion concentration was 0.169. Why is that? Because hydrogen bromide is one of your strong acids. So you get to jump right into the square. Hydrogen ion concentration equals molarity. To get to the pH, oh, they're going across the top again. So anyways, to get to the pH, it's going to be down here. I'm going to take the, remember I'm going down, so that's the negative log of that number, gets me to 0.8. Remember 0.8 and the pOH add up to 14, so that's 13.2. And then to go up, I take the shift log of my negative answer, and I get 13.2. How come I got to go right into the square? Because hydrobromic acid is a strong acid. All right, so I've got hydrogen phosphate, which is phosphoric acid, and given 0.169 molar and a Ka value of 7.1 E negative 3 molar, figure out what the pH, pOH, hydrogen ion concentration, and hydroxide concentration are. All right, disclaimer. It's a little easy to figure out that this is a weak acid from this because in this particular PowerPoint, they only gave you Ka values on the weak acids. But please be aware, on test day, every acid has a Ka value. That's a constant for the acid. Every acid has a Ka value, and they're going to give it to you for every single one of them. So everybody will have a Ka value even when you don't need it. Now, I think it's kind of obvious that I need it here in this PowerPoint because they gave me one and they didn't give me one on the last problem. But be aware, that's not going to happen. So go ahead, pause the video, and come back and see your solution. All right, so of course you know that this was a weak acid. So with a weak acid, you're going to take the square root of your hydrogen, your molarity times your Ka value. So hopefully you got 0.035 molar as your hydrogen ion concentration. Now, if you want to go down, you're going to take the negative log of the answer, and when you do, it's going to be 1.5, and then you're going to take 14 minus 1.5 and get 12.5, and then you're going to want to go up, so you're going to take the shift log of your negative 12.5, and and that's going to get you 2.86 times 10 to the negative 13. That's how you can go all the way around the square. So here's another example. This is nitrous acid, hydrogen nitrite. So that's nitrous acid. If they give you already that the H plus is 0.01, then figure out the remainder if the Ka value is 5.1 times 10 to the negative 4. Oh, they're not telling you they're telling, this is the molarity. So 0.01 molar of this substance, and with the Ka value of that. So that's a weak acid. Oh, did they not tell me the numbers? Oh, I'm going to have to calculate those because they didn't. Oh, did they? Okay, so I will calculate them for you because the next slide doesn't have them on it. So I've got 0.01 times 5.1 to the negative 4. Then I take the square root of that answer. And so my H plus is 0.002. Then I want to take, I'm going down, so I take the negative log of my answer, and my pH is 2.6. Then 14 minus my answer, so my pOH, that's a 6, is 11.4. And then I want to go up to get to my hydroxide ion concentration. So I take I want to go up the shift log of my negative 11.4, and oh, I hit something wrong. That's a bummer. I take the shift log of my negative 11.4, and I get somewhere around, I cleared it, so 3.98 E negative 12. So sorry, these aren't nicely written somewhere. That's at 11. Because that slide somehow is not in this PowerPoint. All right. The next thing that they're going to show me is the strong bases. Strong bases are just like strong acids. Their molarity immediately equals their hydrogen ion concentration. And we are only doing calculations for strong acids. That's true for both honors and regular, so you don't need to worry about weak bases at all. We're only doing strong bases. We are not doing weak bases. You're going to do both strong and weak acids if you're in honors, but you're only doing strong bases, everybody. All right, so if you have a base, you're jumping in on the hydroxide ion concentration of the pool, and then everything works out exactly the same. So it just depends on what side of this pool you're jumping in, to which direction is based on what they gave you. So if they tell you you've got NaOH, then you recognize that as a base. That's not an acid because it's not starting with the element hydrogen. So if they give you the molarity of your base, now you're jumping in on that side of the pool. And remember that for a strong acid, for a strong base, the molarity equals your hydroxide ion concentration. So that automatically is equal to your OH minus. So bam, you're in the pool, and you can start heading around the pool the same way you did before with acids. So you're going to jump into the top corner, and when you jump into the top corner of the pool with whatever number that is, you're going to take the negative log of that number to get to the pOH. Then you're going to do 14 minus your answer to get to the pH. Then you're going to do the shift log of your negative answer to get to the hydrogen ion concentration. So it depends on what number they give you, where you jump into the pool. So now they're telling you, you know the OH minus is 0.15. Then when you go to get to pH, technically speaking, you don't get directly there. So if I'm at 1.5, if I'm right here, and I'm going down, so I take the negative log of 0.15, what I'm going to get is 0.82. Then I take 14 minus my answer, because my answer is 0.82. That's when I get 13.18. Then if I want to go up, I take the shift log of my negative 13.18, and I end up with 6.6 times 10 to the negative 14 as I work my way around. Bases have pHs higher than 7. See, it says 13.8. So I knew I was dealing with a base. Okay. Hopefully you had enough practice problems here to master your calculator.